Hello everyone, welcome to our new problem. The problem looks somewhat like this. So you have a block whose weight is 100 Newton acting perpendicularly vertically downward on the floor. A force capital F has been applied at an angle 37 degree with the horizontal. Coefficient of friction between the block and the floor is 0.5. So as this 100 Newton force is applied on the floor, is acting on the floor will definitely provide a force of normal reaction. This force capital F, which is applied on the block at an angle 37 degree, we can split it into two components. So this will be F cos 37 degree, and in the vertical direction we can get F sine 37 degree. Now you are wondering, what are we supposed to do, right? So this F cos 37 degree will try to pull the block. So there will be a force of friction here. The force of friction. Now our question is, when this force is applied, what happens to the block? Okay. It may sound a bit strange, the question, what happens to the block? So many things can happen. Like if we consider the physics point of view, this F cos 37 will try to slide the block along the floor. F sin 37 will try to lift the block from the floor. So basically we are trying to judge the situation. What happens to the block? Does it get lifted? Does it slide on the floor? Okay. So to get lifted or to slide on the floor, that is the question of the hour. So what we can say, that for equilibrium, so in equilibrium, if I write, what can I say? I can say that normal reaction plus F sine 37, that is equals to 100 Newton. Okay. So sine 37 is 3 by 5. So we can say that normal reaction plus 3F by 5, and that is equals to 100. Now the thing is, if we want to lift the block, if the block gets lifted, then this normal reaction will definitely vanish. If the block gets lifted, then normal reaction will become 0. So you have to apply a force in the upward. This vertical force should be either greater than or equal to 100 Newton. Equal to 100 Newton will just be able to lift it. Okay. So what we can say, that for lifting the condition should be like this: 3F by 5, which is this vertical force, is greater than or equals to 100 Newton. So F should be greater than equals to 500 by 3 Newton. Okay. So the minimum force that we need to lift the block from the floor is 500 by 3 Newton. Now if we want to consider the situation for the block to slide, so for the block to just start sliding, this F cos 37 degree should be greater than or equal to this force of friction. So for the block to slide, this F cos 37, what is F cos 37? 4F by 5. Okay. What is F sin 37? 3F by 5. So what we can say, that 4F by 5 should be greater than or equal to the force of friction. What is force of friction? Mu times normal reaction. So we can say 4F by 5 is greater than equals to, mu is 0.5, and what is normal reaction? From here what we can see, normal reaction is 100 minus 3f by 5. So we can say that 4f by 5 is greater than or equals to 50 minus 0.5. So it is basically 3f by 10. So 4f by 5 basically is nothing but 8f by 10. So it comes to the left side. So this is 8f by 10 plus 3f by 10. So 11f by 10 is greater than or equals to 50. So very clearly what we can say, that f is greater than equals to 500 by 11 Newton. So as we can see that the force needed, the minimum force needed for the block to slide is 500 by 11 Newton, and the minimum force needed for the block to get lifted is 500 by 3 Newton. So this force is greater than this force. So therefore when we start applying this force, at first the block slides and then it gets lifted. So that's our conclusion, that F sliding is less than F lifting. So therefore the block slides at first before it gets lifted. I hope it cleared some fundamental concepts of Newtonian mechanics. Thank you everyone and have a good day.